Okay, the other chapter 5 topic we are going to cover is called function notation. Okay, function notation is representing a rule. It looks like this. It says f parentheses x, and you say f of x, but it could also be g of x, h of t, p of r. But when we see parentheses, it's not actually being multiplied. We say f of x, and it's representing a function notation. Okay, function notation can be used to represent ordered pairs, or it can be used to represent equations of a function, and I'll put an example of each. So for the ordered pair 4, 10, in function notation, I say f of 4 equals 10, and if I'm looking at this, this is the x, this is the y, and the f represents the function you're plugging it into. Okay, so if I'm doing an equation of a function, y equals 2x plus 3, where the y is, I change that to f of x to use function notation. So I would say that y equals 2x plus 3, I would say f of x equals 2x plus 3. So the function notation just changes, represents the y, but you can specify the rule. Okay, so normally in this class, we're going to use function notation to evaluate different functions, and this way we can work with two functions at the same time. Okay, so for this one, it says f of x equals 5x plus 11, g of x equals 2x minus 7. Okay, and then for each of these examples, they're going to tell me to either use the f equation or the g equation and what to plug in. Okay, so let's look at this first one. It says, if I say this out loud, it's f of 3. In the parentheses is the x value. Okay, so I'm going to go ahead and look for the f equation. It tells me f of x equals 5x plus 3. So I'm going to use 5x plus 3, but where the x is, I'm going to substitute 3 because they're telling me, f of 3 is telling me that x equals 3. And then I evaluate this. This is 15 plus 11, so I get 26. Okay, so this is just another way of saying y equals 5x plus 11. Evaluate when x equals 3. This is a nicer way of saying that. Okay, let's go ahead and try the next one. This says f of negative 1, so they're saying plug x equals negative 1 into the f function. So I'm going to look back up here to see what the f function is. The f function is this one, so 5x plus 11 is the rule. So 5 times x plus 11. And then I do evaluate that. So I get f of negative 1 is equal to 6. Okay, I'm going to go ahead and go to C. C says g of 8 equals, okay, so this is my x value. It's telling me to use the g equation, so I'm going to look here. This is g of x equals 2x minus 7. So now I'm plugging x equals 8 into this expression. Two times x minus 7, and then I do evaluate it. So that is g of 8 is equal to 9. Okay, for D, g of negative 4. Okay, so remember, this is my x is negative 4. And for the g expression, I'm using 2x minus 7. And it's just this is just to tell me which equation to plug into. 2 times x minus 7. Which is, they're both minuses, so I'm going to add them up and I get negative 15. So g of negative 4 is equal to negative 15. Okay, now the last few of this type are similar. They just look a little funny with the letters, extra variables. So this is saying g of n. So where the x is, I'm going to replace it with n. Okay, so on the g equation, which is 2x minus 7, where the x is, I'm going to change it to n minus 7. Now, can I simplify that? No, that's the best I can do. So g of n just means 2n minus 7. Okay, so for f, it says f of e. So where the x is in the f equation, I'm going to replace it with e. So the f equation is 5x plus 11. So where the x is, I'm going to replace it with e, substitute the e. 5e plus 11. Now, can I simplify that? No, they're not like terms. So f of e is just 5e plus 11. Okay, for g, it says f of n plus 2. So where the x is, I'm going to replace it with n plus 2, and I'm going to use parentheses because the n plus 2 has to stay together. So for f of x equals 5x plus 11. So where the x is, I'm going to plug in n plus 2. So 5n plus 2 plus 11. Okay, and I put it in parentheses because the n plus 2 have to stay together. I can simplify this, so I'm going to go ahead and simplify this. I can distribute, so 5 times n is 5n, 5 times 2 is 10. So 5n plus 10, let me bring down the plus 11. Okay, 5n, 10 plus 11 is 21. So f of n plus 2 is actually 5n plus 21. Okay, let's try to do something similar with the g function. So this, for h, it says g of n minus 3. So where the x is in the g function, I'm going to replace it with n minus 3. So g of x is 2x minus 7. So 2, instead of x, I'm going to put in n minus 3 minus 7. And I can see that this is going to simplify, so I'm going to simplify it. 2 times 3 is minus 6 minus 7. 2n's okay. Minus 6 minus 7 turns into minus 13. So I'm going to go ahead and go like that. Okay, the last thing we might do with function notation is to find x when you set the g of x equal to something. So in this case, for I, it says find x if g of x equals 13. Okay, they don't tell me what x is. I want to leave the x in the equation, but I do want to see what the g of x equation is. I'm trying to figure out what x is. So let me go back to see what the g of x equation was. The g of x equation is 2x minus 7, right here. Okay, so let me go back down. 2x minus 7, 2x minus 7. Okay, so where the g of x is, I'm going to change it to 2x minus 7. And then it says equals 13. And they want me to find x. Okay, how do I find x? Oh, it's a two-step equation. Let's go ahead and find x. Okay, I got x equals 10. Since the question told me to find x, and I found that x equals 10, I most likely did it correctly. Okay, last example says find f if f of x equals 0. Okay, so I need to find x. They're not giving it to me. So let me go see what the equation for f of x is. The equation for f of x is 5x plus 11. So f of x equals 5x plus 11. 5x plus 11 is equal to 0. They want me to find what the x value is. So I'm going to go ahead and solve this. Minus 11. Is that a fraction? That's a fraction. Okay, so I asked me to find x. I found x. X is negative 11 over 5 when f of x is equal to 0.